Here we are looking at rate of change, which is really slope. So when we want to find measure the steepness of a line that's not straight, like a part of a function, then I can look at an interval of that function and take an average steepness by picking two dots on that function and the secant line between them and find the slope of that secant line. So that uses the formula for slope. So this is really y2 minus y1 over x2 minus x1, where our y's are the corresponding evaluated function values. So, or you can think of this also as rise over run, or change in y over change in x. So a couple different ways to think about that. Let's see that into action. So here is an example similar to our homework problems from 45 to 52, where we have to find the average rate of change of this function and we have two different parts, a and b. So looking at a first, here's my function, 1 minus 2x cubed. And I want to find the rate of change. This should be going from -1 to +2. My formula from above says I do f of 2 minus f of -1 over 2 and -1 minus -1. So make sure, as with slope, you always have to make sure that the x and the y vertically correspond. So make sure that 2 and 2 match, and also that -1 and -1. All right. So now to evaluate this, it gets kind of messy trying to plug everything into the fraction at once. So I like to take it a piece at a time. So I'm going to unhighlight those and just think about this piece, f of 2. So f of 2 equals, remember our function is right here, it's the 1 minus 2x cubed, and instead of x I'm doing the parentheses because instead of x I'm going to write whatever's here. I'm going to plug in a 2 for my input, and then I get 1 minus 2. 2 cubed is 8, which gives me 1 minus 16, which gives me a -15. So the first part of my fraction here is going to be a -15. So that's my this part right here. And then I want minus, and I'm going to find now the f of -1. And f of -1, again, I write that function and we use parentheses in place of the x. So I can plug in whatever's here, and I plug in a -1 for x, and I get 1 minus 2. -1 cubed is -1, which gives me 1 plus 2, which gives me 3. So back to my function over here. So for that green highlight, I'm plugging in a 3. And in the denominator, I already have numbers, so I don't have to evaluate there. So I have 2 minus a -1, which I'll just leave it like that for now. And then to evaluate this guy, I'm going to write these off to the side. To evaluate this thing, -15 minus 3 gives me a -18, and the denominator of 2 minus a -1, so that gives me a 3, which gives me a -6. So my average rate of change for part A between -1 and 2 is a-6. I'm going to call that ARC for short. So that is part A. Okay, let's repeat that process with B. So we're going now from 0 to 3 radical 4. Oh, sorry, cubed root of 4. So again, I'm going to find my f of 0. Oh, I guess it doesn't matter, but f of cubed root of 4 minus f of 0 all over cubed root of 4 minus 0. So let's first find the f of cubed root of 4. So when my function is still 1 minus 2 times x cubed, and now my x is this thing, which is the cubed root of 4. So when I simplify that, I get 1 minus 2 times the cubed and the cubed root cancel each other, and I'm left with just the 4, which gives me 1 minus 8, which gives me a 7. And then the next thing is this piece right here, f of 0, and I plug in a 0 to that function. I get 1 minus 0, which is 1. So to evaluate this, I get this piece right here is the 7 minus f of 0, this piece right here, which was 1, all over cubed root of 4 minus 0 is just the cubed root of 4. So 7 minus 1 is oops. Sorry, this is 1 minus 8. You probably caught that. Should be a negative 7, not a positive 7. So that should be a negative 7. And that gives me a negative 8 over cubed root of 4. So there is my answer for part B.